Human beings have been fascinated with space since they first looked up at the stars in awe. And we are still fascinated, whether on Earth looking up or in space looking down. Each time a spaceship thunders off the launch pad into the infinite silence of space, it is a grand adventure, shared by scientists, astronauts, adventurers, and ordinary Americans, joined by our passion to learn more about our universe, our planet, and ourselves. In less than a half century, we have changed forever our view of who we are and where we come from. We have searched for life on other planets and opened new paths for the explorers of tomorrow in our quest to conquer space, the moon, and beyond.
Dramatic achievements in space which occurred in recent weeks should have made clear to us all the impact of this adventure on the minds of men everywhere who are attempting to make a determination of which road they should take.
The beginning of space exploration was the result of two military powers seeking the ultimate high ground. But if it was born of military aggression, it was inspired by man's common desire to explore a universe we all share. It started at the beginning of the Cold War. The Soviets developed long-range missiles to counter U.S. warplanes based in Europe. The power of these missiles launched the Soviet space program. On October 4th, 1957, an aluminum sphere 2 feet across burst into orbit around the Earth. Its name was Sputnik, and if the signal it beamed back to Earth was faint, it blared loudly in the American consciousness. America had tested 8 Atlas rockets in the late 1950s. 4 exploded or failed to fly. The space race had begun, and the favorite was losing. The country looked for help from the newly formed National Aeronautics and Space Administration. NASA's mission was to meet the challenge mustered by the nation's young president.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
President Kennedy's challenge was embodied in 7 men, each willing, as writer Tom Wolfe put it, to go up in a hurtling piece of machinery and put his hide on the line, and then have the moxie, the reflexes, the experience, the coolness to pull it back in the last yawning moment, and then to go up again the next day. Wolfe dubbed this elusive quality the right stuff.
The criteria was that you had not to be over 35 years of age, you had to be a graduate of a test pilot school, and had to have at least 1,000 hours of jet flying, which was sort of unusual in those days. Having an engineering degree was one of the criteria, and could not be over 6 feet tall. That was due to the size of the spacecraft and the booster itself.
The Mercury 7 made just one demand. They wanted to fly their own spacecraft.
They said, hey, wait a minute, if we're going to go into space, let's make the capsule more so that we have some control over it. And they said that because they were the test pilots. Because before the test pilots went, they had launched dogs.
Space technology was new, and of course everything was different. We were just expanding the envelope, so to speak, going faster, going higher, sitting on engines much more powerful, dealing with high explosives in the fuels. And of course, that was the sort of the creed that test pilots normally live by.
But before the Magnificent Seven could ride their rockets, the Soviets eclipsed them again. On April 12, 1961, Yuri Gagarin became the first man to fly in space. His flight lasted 108 minutes and made him an icon, the hero of a new era. The Soviet propaganda machine made sure the whole world knew. Less than a month later, astronaut Alan Shepard was primed to score one for the USA. As 45 million Americans watched on flickering black and white television sets, he climbed atop a Redstone rocket that packed 33 tons of highly explosive fuel. Shepard told NASA to hurry up and light the candle.
All right, lift off and the clock is started. Yes, sir, reading you loud and clear. This is Freedom 7. The fuel is go, 1.2 G. Cabin at 14 PSI. Oxygen is go.
Americans would soon get used to patter like this, but on that May morning, it was nothing short of miraculous.
Cabin holding at 545.
Gus Grissom was the second American in space. His flight was smooth until splashdown. The hatch of Liberty Bell 7 burst open, and the capsule started sinking fast. Grissom was drowning as his spacesuit took on water. He was rescued, but his capsule disappeared beneath the waves. The investigation was inconclusive, though NASA redesigned the hatch, a change that would later cost Grissom dearly. In August 1961, the Soviets scored again. Cosmonaut German S. Titov orbited the Earth 17 times, spending more than 24 hours in space.
By doing it live rather than as the Russians did, trying to do everything in secret, I think that gave the U.S. a lot more buy-in from the public in terms of this is really important what we're doing, and it's really good for the country what we're doing.
Godspeed, John Glenn.
Astronaut John Glenn roared onto the cosmic racetrack in February 1962 aboard Friendship 7. NASA promised him at least 7 orbits to put America back in the running.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous. Roger, understand, go for at least 7 orbits.
But Glenn was only in orbit number 3 when Mission Control waved him out of the race. Telemetry data indicated a problem with his spacecraft's heat shield. The question was whether Glenn would survive the re-entry burn.
Cabin pressure holding steady at 5.8. Amps is 2.6.
Television viewers were glued to the horrifying play-by-play. A fireball engulfed the spacecraft as man and machine plunged through the atmosphere, wrestling for control as they sped toward the Earth. When Glenn's capsule safely splashed down, there was a collective sigh of relief.
In those first flights, I think the interest was always this fascination of being right on the edge, and everything was new, and so it was totally, any result you got was totally unexpected, and everybody was hoping that it'd be the best, but I think there was sort of a curiosity about, wow, this is really an adrenaline rush to be able to even participate vicariously.
I express the great happiness and thanksgiving of all of us that Colonel Glenn has completed his trip. We have a long way to go in the space race. We started late, but this is the new ocean, and I believe the United States must sail on it and be in a position second to none.
The ideological battle between the world's 2 superpowers was fought on the vast battlefield of space. But it was a war, and there would be casualties.
We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
If the Mercury program had taken Americans into Earth's orbit, the Gemini program would move them ever closer to the president's goal. The fact was, America still lagged in the space race, and there was only one way they could win: by landing the first man on the moon.
Gemini then looked at those systems that were required to actually go to the moon at that time, also to examine the human ability to stay in space at least 2 weeks. That was the maximum length of time to go to the moon and come back again.
The Gemini craft also had a hatch and pressure system, so astronauts could do EVA.
Okay, I'm out.
Extravehicular activity, spacewalks. In June 1965, Ed White was the first American to step into the abyss.
You're right, son, Ed. You look beautiful. I feel like $1 million. I'll go pick up.
The Gemini 7 mission became the next proving ground by default.
Gemini 6 was designated to be the first attempt to rendezvous with an unmanned vehicle called an Agena. But when they tried to launch, the Agena was lost. We had to develop a system quite rapidly to see if rendezvous was possible. Now, Gemini 7 was the next flight. It was a 2-week mission. Launch crews at the Kennedy Space Center were able to launch Gemini 6 on our 12th day in space. We did not have a docking mechanism on 7, so they could not dock with us, but at least we could determine where the rendezvous was possible.
Astronaut Wally Schirra maneuvered Gemini 6 to within 1 foot of Lovell's craft. If Gemini's success propelled NASA closer to putting a man on the moon, the Apollo program would go the distance. On January 27, 1967, the crew of Apollo 1, Gus Grissom, Ed White, and Roger Chaffee, entered their spacecraft for a pre-flight test. As they rehearsed for launch, flames ignited the inside of a capsule filled with pure oxygen. The quick-release hatch that opened prematurely during Grissom's Mercury flight could have saved their lives, but it had been replaced with a hatch that had to be pried off, and there was no time. The 3 crew members perished.
Thoughts of those days, of course, were that if we have any accidents, they'd be in flight or on the moon or around the Earth, and some of that, maybe should be expected in a program of this nature, but not 3 deaths sitting on the launch pad, just doing a test.
The next casualty was Soviet. In April 1967, Soyuz 1 thundered off the launch pad carrying Colonel Vladimir Komarov. When problems developed, controllers attempted to bring him down early. But on re-entry, his craft's parachute didn't open, and he dropped from the sky at over 300 miles an hour. In October of 1968, Apollo 7 sat on the launch pad atop a mammoth Saturn rocket as powerful as an atomic bomb. It would be the first manned flight since the Apollo 1 disaster. In almost 11 days in Earth orbit, the 3 crew members rehearsed every operation that would take their successors to the moon and sent home the pictures to prove it. The message was loud and clear. The home team had the advantage. As the dark and tumultuous year of 1968 drew to a close, Apollo 8 lit up the sky.
We have liftoff. Liftoff at 7:50.
As the spacecraft neared the moon on Christmas Eve, NASA took a gamble.
Apollo 8 Houston, you are go for TLI, over. Roger, understand, we're go for TLI.
They ordered Apollo 8 onto a trajectory tested only in scientists' computations. On that holiday eve, the crew fired their craft into the moon's orbit on a leap of faith. The slightest miscalculation would mean disaster. For 20 minutes, the spacecraft was out of radio range as it slipped behind the moon.
Apollo 8 was perhaps my most impressive flight that I was on. It was the peak of my flight experience. 13 was a real challenge for me, but 8 was the one I remember being one of the first three people to go to the moon, to orbit the moon, seeing the far side, which we do not see from the Earth, to ride the Saturn V for the very first time, and to be on a flight that was very, very successful.
Apollo 8 made 10 lunar orbits and took some of the most famous photographs in history. They also sent home some Christmas cheer.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
As the turbulent 1960s drew to a close, the space program and astronauts sometimes seemed the only stars Americans could look up to. Apollo 9 and 10 successfully tested the Lunar Excursion Module, the LEM that would land a man on the moon. In the lingo of NASA, all systems were now go. On July 16, 1969, at 9:32 a.m., Apollo 11 began its momentous journey with astronauts Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins at the controls. More than 500,000 people watched from the Kennedy Space Center, and millions more from their living rooms. The voyage from the Earth to the Moon took 4 days. On July 20th, Armstrong and Aldrin settled the lunar module Eagle onto a landing zone known as the Sea of Tranquility. Then Armstrong phoned home.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Astronaut Neil Armstrong stepped out of the Apollo 11 spacecraft into a new era in human history.
That's one small step for man, one giant leap for mankind.
NASA had met President Kennedy's challenge. Almost 7 years after his death, America won the race to the moon.
The assassination of President Kennedy, of course, was very close to us because it was Kennedy who, in a very bold speech, said that we plan to go to the moon and land a man on the moon prior to the end of the decade.
With the second successful moon landing by Apollo 12, it seemed that NASA had mastered the art of space travel. So when Apollo 13 left the launch pad in April 1970 with James Lovell, Jack Swigert, and Fred Hayes on board, America expected smooth sailing.
Okay, Houston, we've had a problem here.
But that wasn't the case. After leaving Earth's orbit for the moon, a liquid oxygen tank exploded. As mission control determined the extent of the damage, the mission's focus changed from a lunar landing to simply a safe return to Earth. The crew would use the lunar module as a lifeboat. But could a module designed to support 2 people for 2 days support 3 for more than 3 days? It would take that long for Apollo 13 to make its roundabout journey home. Concerned the main engine was damaged, the crew would travel around the moon and use its gravity to help propel them back to Earth. But would their fuel, water, oxygen, and battery power last long enough for the journey home? As the spacecraft neared the Earth's atmosphere, there were more terrifying questions. What if the heat shield had been damaged, as Mission Control feared? Could the crew survive the 5,000-degree heat of re-entry? And if they did, would their parachutes deploy? As Apollo 13 re-entered Earth's atmosphere, passing through the communications blackout, all ears strained to hear sounds of life.
Roger, Apollo 13, this is recovery, and your chutes look good. Apollo 1 observes flight down at this time.
This was a case where people then got together using, good leadership in the form of Gene Kranz and his Tiger team, using teamwork, working together, and having their initiative to try to figure out how to solve crisis, and having the perseverance to keep working on solutions to get us back home safely.
Hippity-hoppity, hippity-hoppity, hippity-hopping over hill and dale.
There were 4 more moon missions, all successful despite a galaxy of glitches and near misses.
No, dadgummit. Ignition. Run away, Houston.
But if the race to the moon was won, the space race itself was still on. It simply went interplanetary.
What's most interesting is that the country and NASA is embarked on a more in-depth investigation in order to understand life. Where did we come from? Why has Earth evolved so much differently than the other planets?
What astronomy does is it helps you understand your role in the larger universe. The big question right now is how many other Earths are there?
I think by exploring our neighborhood, and that's all our solar system is, it's a neighborhood, we get to learn about ourselves. We're learning about the limits of technology to explore environments, and we're searching for the stuff of life.
Pioneer 10 and 11 were actually originally destined to see whether we could get through the asteroid belt, that rocky belt between Mars and Jupiter. So what we were trying to do is see, could a spacecraft survive in that area? And so this first encounter with Jupiter showed us a world that was constantly changing when we thought it was not undergoing that kind of change.
And I remember vividly when the first pictures came back of the Galilean moons, the big moons around Jupiter. Now, it took Galileo to produce the slam dunk that said this Europa, the second big inner moon of Jupiter, could harbor an internal energy source, a system that could actually be hiding a subsurface liquid water ocean.
Galileo basically set the stage, and it did so for each of the icy moons as well. On Io, where we thought we were going to find this cratered world, we found geysers, some of the biggest volcanoes in the solar system, and it spews volcanic material at 100 times the amount of volcanic material being spewed on the Earth. So it's unbelievably active.
And they looked at Io, of course, as well as the other large Galilean satellites, Ganymede, Callisto, and the other oodles of moons, and they saw a microcosm of a solar system. Voyager 1 and 2 both went to the Saturn system, uncovering even more phenomenal worlds. And then NASA, thanks to the flexibility of the design of Voyager, allowed one of the Voyagers to proceed to encounter Uranus and Neptune, completing a grand tour that was only a dream in the eyes of the original mission architects in the 1960s.
We've had more than 30 successful missions to the outer planets, but these are basically mostly flyby missions. You are getting a very quick glimpse of the planet as you go by. So that's the first stage of us understanding the 9 planets around us and also the icy moons and bodies. The next step is to actually orbit those planets and get a more in-depth investigation than this quick take a glance at your object kind of flyby.
The history of exploration of Mars is one of those topsy-turvy tales, pretty much like the history of exploration of our own planet. We thought something, we got it wrong. Mother Nature didn't cooperate. So We looked at Mars for centuries through telescopes, and we saw a changing face, lines, markings, ice caps. It looked like a very habitable world. But on our first flyby, 1965, a long time ago, what we saw of Mars was lunar. So one flyby, 20 pictures at weather satellite resolution does not a story make. And NASA's first planetary orbiter spacecraft, a robot probe called Mariner 9, launched in 1971, arrived at Mars to orbit the planet. And in a period of 6 months, we acquired thousands of images that showed us the real Mars for the first time. And what did we find? We found an Earth-like planet in some ways. Gigantic volcanoes. So big, they're still the biggest we've yet to find in our solar system. River valleys, carving networks, trellis works, lace works, if you will, of landscapes. Giant dune fields, layers galore, inside canyon systems that would run from Los Angeles to New York, deeper than any we've ever imagined on a planet the size of Mars, which is only about 40% the size of the Earth. So we saw a new face of Mars, and that's when we really ramped up our planning for what became the Viking mission, the first robotic probes to look for life on another world. We dug around in the soil and conducted 5 life-related experiments. Not for a week, not for a month, but for years, exploring the weather, the nature of the soils, the chemistry of the atmosphere, all designed to understand the real Mars, to set up for asking, does Mars have a life force today? In the early 90s, NASA thought that it would be good to find a more cost-effective way of landing on the surface of Mars. So we came up with Pathfinder, landing a microwave oven-sized mobile device with a big lander that goes with it in a cocoon of airbags, extra heavy-duty airbags that would protect it from falling 50 feet from the sky when the parachutes and all the other gear that got it through the Mars atmosphere let go, and bring it down to the surface safely. And as good fortune would have it, and the Mars gods, it was phenomenally successful. It opened the door for true mobility on another planetary surface. So here we are, about poised to explore Mars at human scale with tools that are a lot like those we would use in the field if we were on Mars. We will be doing real vicarious overland exploration in 2004 in places where we think there was a record of liquid water on the ground. And our tools on these exquisite rovers named Spirit and Opportunity, they'll explore like we do. It'll be the first time ever human beings have done that remotely on another world. We're going to do that to look at Mars, to really lay the groundwork to find where we're going to have to send the next generation probes. And ultimately, even potentially, plan the landing sites where someday, we all hope, where human beings may get to go.
Since the Apollo days, we haven't returned anything from the solar system back to Earth until now. We have 2 missions that are about to return samples. One is called Genesis, and it's going to return solar particles that it's captured, and that's the first ever non-lunar planetary return mission to Earth. We also have a mission called Stardust, and it's going to go to Comet Built 2 and grab some of the particles in the tail of the comet, and we will actually be able to analyze these objects. And once again, it's entirely possible that the volatiles on Earth, water on Earth, actually came from some of these objects, from the pristine primordial material in the solar system that exists in these objects. So it is fun and interesting to note that from a historical long look point of view that we really do come from stardust, that these outer members of our solar system may be the origins of life as we know it.
Today, as we explore the planets with our robot probes, we also look way beyond with our telescopic program of exploration for clues to our origins, other solar systems, ultimately other Earths.
Well, right now we have 3 great observatories up and flying, one in the optical, one in the X-ray, and one in the infrared. With the optical telescope with Hubble, we can see farther back than we've ever seen before. Because of the amount of time that it takes for light to travel to us, you're actually looking at the universe in the past. Space is so big that it takes a long time for light to get to us. So we are seeing galaxies that are 10 billion light years away. And so it is teaching you how modern galaxies emerged and completely changed our picture on when galaxies formed. It turns out they formed much, much earlier in the universe than we thought. And so you can sort of trace back the life of the star in these images. It's almost like going back in layers of fossils. You can literally tell what has been happening, over a period of some billions of years. The X-ray telescope Chandra, you're able to change your view of those galaxies and look at black holes in the centers of the galaxies, the things that are emitting at a million degrees instead of thousands of degrees, the most energetic, explosive, violent events in the universe. And the infrared telescope that we just launched can see things at hundreds of degrees instead of at thousands of degrees. Infrared, you can see either the dust that emits, or you can see the cold gas, regions that are forming stars or forming planets.
We thought that our planetary system was it. We didn't really see a planetary system like ours ever before. And now we have seen 115 planets.
The long-term vision at NASA is to eventually build a terrestrial planet finder and to go after Earth-like planets in our vicinity here in the local solar neighborhood. I think we're going to find that intelligent life is rare because it's so hard. It takes a perfect planet to create life. And we have a perfect planet. I don't think there's going to be a lot of them out there. It's hard to imagine there aren't any out there.
All of a sudden, space isn't friendly. All of a sudden, it's a place where people can die. Many people are going to die, but we can't let that stop us. We can't explore space if the requirement is that there be no casualties.
As NASA's unmanned spacecraft found where Earth fit into the grand scheme of the solar system, human explorers looked for their niche in space too. They tested the thin air with ever longer flights. In 1973, America launched the Skylab space station, a true orbital laboratory visited by crews shuttled up and back in command modules. It was science fiction come to life. Skylab supported scores of experiments in science and astronomy and attempted to answer another of man's probing questions. Could human beings live and work in space for extended periods of time? America had its first glimpse of long-term life in microgravity, and it seemed we had a future there. In July of 1975, NASA explored an even greater challenge. Could we live in microgravity with our Soviet competitors? The Apollo-Soyuz test project was a cooperative effort between the U.S. and the USSR. Astronaut Tom Stafford inched Apollo to a perfect docking with Soyuz.
Contact. Capture. We also have capture.
When he opened the hatch and entered the Soviet craft, the two rivals finally found themselves on the same side.
Glad to see you.
Space gives us a venue to work together on something that we all mutually agree on, essentially, that could give us a closer rapport with our other countries, and because the Earth is getting smaller due to communication, and what happens in this country affects other countries, and what happens over there affects this country.
20 years to the day of cosmonaut Yuri Gagarin's first spaceflight, the United States space program realized the vision of the Mercury test pilots. On April 12, 1981, the space shuttle Columbia sat on the launch pad at the Kennedy Space Center. This was no space capsule. The shuttle had wings and needed a pilot to fly it. Navy Captain Robert L. Crippen and John W. Young, one of the 12 Americans who had walked on the moon, were at the stick.
America's first space shuttle, and the shuttle has cleared the tower.
Columbia was the first spacecraft to land like an airplane, rather than splashing down like a vehicle in distress.
The shuttle was sort of that do-all for everybody. I mean, you could launch satellites from it, you could do research in it, you could do technology demonstrations in it, and it was more of a semis that hauled stuff from the source of the resource into the place where it needs to be transported.
In 1983, the seventh shuttle mission brought the first American woman into space, Sally Ride. On the eighth shuttle flight was Air Force Colonel Guyon S. Bluford, Jr., the first African-American in space. In 1985, Challenger ferried Space Lab 3 into orbit, a pressurized 15-ton modular lab filled with science experiments assembled by the European Space Agency and NASA. It was a glimpse of things to come.
The objectives were to start to utilize, from a science standpoint, this new tool of actually being able to use the low-gravity environment to look at things that had never been able to be done before.
In 1990, the shuttle Discovery deployed the Hubble Space Telescope.
Hubble started out with a huge failure, of course. Its mirror, which was advertised to be the best mirror that had ever been made, of course, it was a perfect mirror. It was just that it was perfectly wrong. It was in the wrong shape.
Then the crew of a later Endeavour mission corrected Hubble's vision using the shuttle's dexterous robot arm.
The end result, after the thing was corrected, was that we started seeing, gangbuster images that were just spectacularly beautiful and also very, very relevant to the science that was being done with Hubble. If we hadn't had shuttle available to us to fix the Hubble, Hubble would not have had the impact on science that it had, but it was designed to be serviceable. And if it hadn't been, it really would have been a failure. We would not have been able to retrieve much science on Hubble. Shuttle and Hubble went hand in hand.
But the shuttle program taught some painful lessons, too. In 1986, school teacher Krista McAuliffe was prepared to become the first citizen passenger. The launch of Challenger was postponed 3 times and scrubbed once due to unseasonably cold weather at the Cape. Some recommended another delay, but the next launch window wasn't until April.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
So Challenger left the launch pad as planned.
Challenger, go at throttle up.
Roger, go at throttle up.
Sometimes when we reach for the stars, we fall short. But we must pick ourselves up again and press on, despite the pain. The best we can do is remember our 7 astronauts, our Challenger 7. Remember them as they lived, bringing life and love and joy to those who knew them, and pride to a nation.
The Blue Ribbon Presidential Commission that studied the disaster found that a rubber O-ring, made brittle by the cold, had ruptured in the tremendous heat and pressure of liftoff. Just weeks later, the Soviets launched into orbit the core module of their new space station, Mir, whose name meant peace. Mir was roughly the size of a 2-bedroom apartment, cramped, noisy, suffocating, and wonderful, At the time, the only place where people could learn to live off the planet. Mir's residents experimented with growing food, practicing medicine, and just figuring out what worked and what didn't in outer space. But by 1991, the Soviet Union collapsed, and the future of Mir was uncertain, when NASA engineered a plan. Mir provided a welcome opportunity for the U.S. to resume long-term space travel. In 1994, the Americans began sending astronauts to the Russian outpost. The idea of working together had both scientific and diplomatic appeal, but an aging spacecraft would test the mettle of everyone involved. On Mir, astronauts and cosmonauts lived and worked together for months at a time. They began to see how common things behaved in an uncommon environment, and how they themselves behaved. Mir was the stage for many firsts. The first shuttle link-up, when Atlantis docked with Mir. The first American on Mir, Dr. Norman E. Thagard. And the first time 10 people were in space together, 6 Americans and 4 Russians. It was also the first time Americans conducted long-term microgravity experiments since Skylab. Shannon Lucid, the astronaut who spent the longest time on Mir, was among the scientists.
And I had more time that I could do the experiment and I could look at the results and talk with the principal investigator, and then we could decide that, well, we needed to change a little bit to get the results that we really needed. And it was also that I had more control of what I was doing. I was operating more like a scientist when I was on Mir.
But everything on Mir did not follow the public relations script. The cosmic camper was aging, and not gracefully. In 1996, the unthinkable happened. Fire. A quick-witted crew managed to save the ship and survive, but a decompression disaster followed. With lessons learned from Mir, NASA turned its attention to a new and better home away from home, the International Space Station. 16 nations joined together to build a base for deeper understanding of the universe. In 1998, the first 2 modules were launched and joined in orbit. Other modules soon followed, each a complete research lab dedicated to medicine, biology, or other sciences. The first crew arrived in the year 2000. Besides science and technology, the crews on the ISS study habitability concerns. Tomorrow's missions will leave spacefarers isolated in cramped quarters for years. International crews will bring varied languages and cultures to the mix.
What we hope to accomplish with Space Station is that we will be able to find any problem that might start to crop up with human beings living in microgravity for long durations of time. We hope to be able to see it and be able to understand it and to be able to have countermeasures for it before we venture out from low Earth orbit, before we leave the shoreline, so to speak.
So someday people have to go to Mars. We can't say when. What we can say is we're going to do the homework right now to put all the information we need to make the tough design choices. The shortest round trip is more than a year that we can imagine using projections of today's technology.
There are many other questions, too. Is it possible to perform surgery in space? Will animals and humans born off the planet be psychologically and physically normal? Can food be cultivated? Water produced? Humans have become so comfortable with life in space that sometimes we forget how dangerous it is. But those who venture there put their lives on the line every day.
Don,
It's really neat. It's a bright orange, yellow, out over the nose, all around the nose.
In Columbia, Houston, we see your tire pressure messages, and we did not copy
Is it
your last.
instrumentation, Max?
Flight Max, but also off. We've also lost the nose gear down talk back and the right main gear down talk back.
I've got 4 temperature sensors on the bond line data that are off scale low.
GC flight. Flight GC. Lock the doors. Copy.
To make progress, I think you have to take risks. By taking those risks, we open new doors, new avenues that allow more things to have an impact on the enhancement of the quality of life here on Earth.
We're thinking about what are the stepping stones that we need to have in place so that we will be able to leave low Earth orbit and so that we will be able to head wherever the science drives us to go in our vast universe.
Where did we come from? Why has Earth evolved so much differently than the other planets? Why is Mars now cold and inhospitable, whereas Earth life flourishes?
I think it's important to keep intellectual exploration going as a human activity. It's important to have a concept of change and progress.
The humans working together in space, looking back at the Earth, can learn a lot about the Earth that would help the people today. A continuing program, especially when we work with other countries, is worth every cent that we spend for it.
In less than a half century, America's space program has reached planets that have captivated us since the beginning of history and watched the birth of galaxies that date back to the beginning of time. Our explorations have improved life on Earth and broadened our understanding of our own planet, even as we look for life beyond. Most of all, we have been inspired to think, to dream, to reach for the stars, to encourage the next generation of explorers to journey ever farther into the universe.